Good morning, sir. This is Bhavya Jha from Computer Science and Engineering Department from first year, and today I'm here to give a presentation on working of nuclear power plant. So, the outline of the presentation is Introduction to Nuclear Energy, what is nuclear energy, components of a nuclear power plant, nuclear reactor, fuel and fuel rods, coolant system, steam generation, turbine and generator, safety measures and environmental impacts, and finally conclusion. So, introduction to nuclear energy. Nuclear energy basics. Nuclear energy is derived from the process of nuclear fission, where the nucleus of an atom is split, releasing a tremendous amount of energy. Energy density and efficiency. Nuclear energy has an incredibly high energy density compared to other sources like fossil fuels. A small amount of nuclear fuel can generate a large amount of energy. Low greenhouse gas emission. Unlike fossil fuels, nuclear energy production does not emit greenhouse gases like carbon dioxide during the electricity generation process. This slide is about the discussion of what is nuclear energy. So the definition of nuclear energy is that it is released when the nucleus of an atom is split, that is nuclear fission, or when atomic nuclei combine, what we know as nuclear fusion. This process generates a tremendous amount of heat energy. Energy conversion and electricity. In nuclear power plants, controlled nuclear reactions produce heat which is used to create steam from water. Components of nuclear power plant. So in general, we have three very important components of nuclear power plant. The reactant core, the cooling system, and the steam generator, or what we know as turbine. So coming over to reactor core, the heart of nuclear power plant is the reactor core, where controlled nuclear fission takes place. The cooling system. A crucial component is the cooling system, which prevents the reactor from overheating. Steam generator and turbine. The heat generated in the reactor is transferred to a secondary loop, where it heats water to create steam. This steam is directed towards a turbine. The turbine is in turn rotated, and that gives weight to energy. So, nuclear reactor in detail. Nuclear fission process. Nuclear reactor facilitate controlled nuclear fission, where atoms, typically uranium or plutonium, split into smaller fragments, releasing a significant amount of energy in the form of heat. Safety and containment. Safety measures are paramount in nuclear reactors to prevent accidents and ensure proper functioning. Multiple layers of containment systems are in place to mitigate the risk of radiation leaks or coal meltdowns. So once actually there was a nuclear power plant disaster that took place because of mishandling or uncontrolled nuclear fission, and that took place in Chernobyl in Ukraine. So fuel and fuel rods. Nuclear fuel. Nuclear power plants primarily use enriched uranium as fuel. Enriched uranium contains a higher concentration of the isotope uranium-235, which is more easily split by neutrons, initiating the nuclear fission process. Sometimes plutonium is also used. Fuel rods. Fuel rods are slender metal tubes containing the nuclear fuel pellets. Coolant system in detail. So the heat regulation and transfer and steam generation. The primary purpose of the cooling system is to manage and transfer the heat generated within the reactor core. It absorbs heat from the nuclear reactions to prevent overheating of the core. Steam generation. As the coolant absorbs heat from the reactor core, it reaches high temperatures and pressures. This hot coolant is then directed to a secondary loop where it transfers its heat to a separate water source. Now let's talk about steam generation. So heat transfer process, steam turbines and electricity generation in detail. Heat transfer process. The nuclear reactor produces an immense amount of heat through controlled nuclear fission. The reaction is always controlled because if by mistake it leads to uncontrolled reaction, then it might lead to some disaster or some hazardous situation where the entire region becomes radioactive. Steam turbines. The high pressure system produced from the heat exchanger is directed towards turbines. Electricity generation. The spinning turbines are connected to electrical generators, converting the mechanical energy from the turbines into electrical energy. Turbine and generator. Turbine. The steam produced by the heat generated in the nuclear reactor is directed towards turbines. These turbines are designed with blades that are spun by the high pressure system. Generator. The spinning turbines are connected to electrical generators. The rotational motion of the turbines drives this generator's rotor, which is surrounded by a stationary magnetic field. These components work together in the nuclear power plant to convert the kinetic energy from steam into mechanical energy in the turbine for practical use. Now let's talk about the safety measures and environmental impact. This slide mainly discusses about safety measures, that are the containment systems. Nuclear power plants are equipped with multiple layers of containment systems to prevent radiation leaks and ensure safety. Emergency shutdown protocols. Plants are equipped with SCRAM or Safety Control Rod Axeman that immediately shuts down the nuclear reaction in case of emergencies or uncontrolled nuclear reaction. Strict regulatory oversight. The strictest regulations and rigorous inspections by nuclear regulatory bodies ensure that nuclear plants adhere to strict safety protocols. The next slide will be discussing about the environmental impacts. Low greenhouse gas emissions. Nuclear power generation produces minimal greenhouse gas emissions during electricity production, unlike fossil fuel-based power plants. Radioactive waste management. The disposal of radioactive waste from nuclear power plants proposes a long-term environmental challenge. Water usage and thermal pollution. Nuclear power plants often require substantial amounts of water for cooling purposes. The release of warm water back into natural water bodies can lead to thermal or environmental pollutions that affects the aquatic ecosystem in the water body. Finally, we have the conclusion slide. So low carbon energy source. Nuclear power plants play a crucial role in providing a low carbon energy alternative. They are reliable baseload power. Nuclear power plants offer a stable and reliable source of baseload electricity. Energy security and diversification. So the diversification of energy sources is essential for nuclear security and energy security. Now, in the 21st century, we have a large demand of energy because there's a lot of industrialization and urbanization going on. So with this large demand in energy, the conventional fuel plants or thermal power plants cannot meet up these demands as they are all renewable sources of energy. But nuclear power plant is a very reliable option. It's very convenient option since it takes very less amount of time for producing a large amount of energy. The only thing that we need to take care in nuclear power plant is a proper safety protocol has to be followed. Because if we don't follow a proper safety measure or controlled nuclear fission process, then it might lead to some undesirable or unnecessary outputs that may be harmful for the human race or the environment as a whole. So altogether, nuclear energy or nuclear power plants are a very good source of energy. And with this, I conclude my presentation. So thank you. This is the presentation by Bhavya Jha from Computer Science and Engineering Department, first year. Thank you.